Hello, students. Hello, and welcome to this video on mathematical induction. In this video, we will solve question number 21 to 30. The link to download the PDF will be in description, as well as at the end, I will show you how you can download and maintain a updated copy of the book. As well as I will show you my question answer website where you can come and ask questions, because YouTube is not really suitable for mathematical content. So without further ado, let's get started. Next question is related to trigonometry. So if you are not studying trigonometry, you can skip this question and come back later. So question 21 says that show that tan alpha plus 2 tan 2 alpha plus 2 square tan 2 square alpha and so on up to 2 raised to the power n minus 1 tan 2 raised to the power n minus 1 alpha is equal to cot alpha minus 2 raised to the power n cos 2 raised to the power cos 2 raised to the power n alpha. So we let the given expression to be Bn, we substitute n is equal to 1 and tan alpha is equal to cot alpha minus 2 cos 2 alpha. So what we do is that we convert cot alpha into tan alpha, that is right hand side becomes 1 by tan alpha minus 2 by tan 2 alpha. And 2 by tan 2 alpha can be written as 1 by tan alpha minus 1 minus tan alpha by tan alpha. So we solve this and you get tan alpha as the answer. So this means that Pn is true for n is equal to 1. We let it be true for n is equal to k. So we have this relationship. Now we add 2 to the power k tan 2 to the power k alpha. The left hand side becomes pk plus 1 and right hand side becomes cot alpha minus 2 to the power k cos 2 raised to the power 2 alpha plus 2 to the power k tan 2 to the power k alpha. So we take cot alpha, we put cot alpha minus, we take 2 to the power k. Normally we have got cot 2 to the power k alpha minus tan 2 to the power k alpha. Now this we can write as 1 minus tan 2 to the power k plus 1 alpha divided by 2 tan 2 to the power k alpha, which is equivalent to cot 2 to the power k plus 1 alpha. Hence, by induction, we have the proofs. Question 22 says that so that tan inverse 1 over 3 plus tan inverse 1 over 7 and so on up to tan inverse 1 over n square plus n plus 1 is equal to tan inverse n over n plus 2. So we take the expression as Pn, we substitute n is equal to 1, which is tan square 1 by 3, which is equal to tan inverse 1 by 1 plus 2. So what we do here is we put n is equal to 1, right? So it is true for n is equal to 1, we let it be true for n is equal to 2. So we have this relationship here. And then we add tan inverse 1 over a square of 3k plus 3 to both sides. Left hand side will become pk plus 1 and right hand side will become tan inverse k over k plus 2 plus tan inverse 1 over k square plus 3k plus 1. And when we do the trigonometric manipulation, we arrive at tan inverse k plus 1 by k plus 3. And hence, by mathematical induction, we have the result. Question 23 says that if u1 is equal to 1, u2 is equal to 1, and un plus 2 is equal to un plus 1 plus un, and greater than equal to 1. So we have to prove that un is equal to 1 over square root of 5 multiplied by 1 plus square root of 5 over 2 whole to the power n minus 1 minus square root of 5 by 2 whole to the power n, where n is greater than equal to 1. So u3 is equal to u2 plus 1. We substitute n is equal to 3 and we see that u3 is indeed equal to u1 plus u2. So the relation holds for n is equal to 3. We can prove that it holds for n is equal to 1 and 2. Let it hold for n is equal to k and k plus 1. So we have uk and uk plus 1. Right? Now we for the UK plus 2, it will be equal to UK plus 1. And we solve this. And we arrive at the result that it is indeed equal to UK plus 2. And hence, by mathematical induction, we have the result. Question 24 says that if P is in the set of natural numbers, we have to show that P raised to the power n plus 1 plus P plus 1 raised to the power 2n minus 1 is divisible by P square plus P plus 1 for every positive integer state. So we'll let P1 is equal to Pn is equal to given expression, then n is equal to 1 gives us P square plus P plus 1, which is divisible by P square plus P plus 1. So it is true for n is equal to 1, let it be true for n is equal to k. So Pk is equal to P raised to the power k plus 1 plus P plus 1 raised to the power 2k plus 1 is divisible by P square plus P plus 1, that is, left-hand side is equal to P square plus P plus 1 multiplied by Qp, where Qp is a polynomial of P. Now we take Pk plus 1, we then get P raised to the power k plus 2 plus P plus 1 raised to the power 2k plus 1. And we split it into two parts. We write Pk plus 2 as P into Pk plus 1, and P plus 1 raised to the power 2k plus 1, we write as P plus 1 whole square, P plus 1 to the power 2k plus 1, which is equal to P square plus P plus 1 whole square Qk, making it divisible by P square plus P plus 1. Hence, by mathematical induction, we have proven the result. Question 25 says that show that 2 to the power n greater than 2n plus 1 for all n greater than 2. So we let given expression be Pn. So for n greater than 2, let me see this quickly, n greater than 2, yeah. So we put n is equal to 3, we get 2 to the power 3 is equal to 8. And right hand side becomes 2 into 3 plus 1 is equal to 7. So it is 2 for n is equal to 3, we let it be 2 for n is equal to k. So the relationship becomes 2 to the power k greater than 2k plus 1, that is where k is greater than 2. Now we consider pk plus 1, so left hand side becomes 2 to the power k plus 1, that is 2 into 2 to the power k plus 1. Now 2 to the power k is equal to 2 plus 1, we substitute here, it becomes 4k plus 2, which is equal to 2k plus 2k plus 2. Since k is greater than 3, greater than equal to 3, 2k plus 2 greater than equal to 3, making our statement true. For n is equal to k plus 1, hence by mathematical induction, we have the result. Question 26 says that so that 2 to the power n greater than n cube if n greater than equal to 10. So, sorry, yeah. Okay, we have got problem, we need to this. Okay. So here n is greater than equal to 10, so we substitute n is equal to 10. We get 2 to the power 10 is equal to 1024 greater than 10 cube, that is 1000. So it is 2 for n is equal to 10, and this should be 10. Okay. Let it be true for n is equal to k, so 2 to the power k is greater than k cube. Now we consider pk plus 1, so it becomes 2 to the power k plus 1 greater than, it should be k, yeah, this we have split, so it becomes 2 into k cube, which is greater than k plus 1 whole cube. This should be equal, this is not greater than. So we expand, we bring everything to one side, so we get k cube minus 3k square minus 3k minus 1 greater than 0. That is k minus 1 whole cube minus 6k greater than 0. Let k is equal to 10 plus a, where a greater than equal to 0. So it becomes 9 plus a whole cube minus 60a minus 6a minus 60 minus 6a, which is equal to 669 plus 183a plus 27a square plus a cube, which is greater than 0. And hence by mathematical induction, we have the result. Question 27 says that show that tan and alpha greater than n tan alpha where 0 less than alpha less than pi by 4n minus 1 for all n in natural numbers greater than 1. So we let n is equal to 2. So we have got tan 2 alpha is equal to 2 tan alpha by 1 minus tan square alpha greater than 2 tan alpha. Because 1 minus tan alpha is less than 1. which is true for n is equal to 2. We let this statement be true for n is equal to k. So tan k alpha greater than k tan alpha for n is equal to k plus 1. We have tan k plus 1 alpha is equal to tan alpha plus tan k alpha by 1 minus tan alpha into tan k alpha, which is greater than k tan alpha plus tan alpha divided by 1 minus tan k alpha tan alpha, which is greater than k plus 1 tan alpha, because 1 minus tan alpha tan k alpha less than 1. Hence, by induction, we have the result. Question 28 says that show that n raised to the power 4 less than 10 raised to the power n for all n greater than equal to 2. So for n is equal to 1, P2, sorry, this should be 2. Okay. P2 is 2 to the power 4 less than 10 square. 16 is less than 100, which is 2 for n is equal to 2. We let Pk be true, that is k to the power 4 less than 10 to the power k. Now k plus 1, Pk plus 1 is k plus 1 raised to the power 4 less than equal to 10 to the power k plus 1. Now clearly 10 to the power k plus 1 greater than 10 to the power k4. Okay, because we multiply 10 in this both sides. Now 10 raised to the power k, 10k raised to the power 4 divided by k plus 1 raised to the power 4 is equal to 10k by k plus 1 raised to the power 4. Now k is greater than equal to 2. So this will be greater than equal to 2 to the power 4 by 3 to the power 4. Hence 10 into k by k plus 1 to the power 4 is greater than equal to 1. And that's how we prove that 10 raised to the power k plus 1 greater than k plus 1 to the power 4. Hence by induction we have the result. Question 29 says that show that 1 cube plus 2 cube and so on up to 1 plus 2n minus 1 whole cube is equal to n square multiplied by 2n square minus 1. We let the given expression as Pn. For P1, 1 cube is equal to 1, which is 2 for n is equal to 1. Let it be 2 for n is equal to k. So 1 cube plus 3 cube up to 2k minus 1 whole cube is equal to k square multiplied by 2k square minus 1. Now we add 2k plus 1 whole cube with both sides. Left hand side becomes pk plus 1 and right hand side becomes k square multiplied by 2k square minus 1 plus 2k plus 1 whole cube. Now it's a matter of simple algebraic manipulation to get the right hand side as k plus 1 whole square multiplied by 2k plus 1 whole square minus 1, and thus by induction we have the result. Question 30 says that show that 3 times 2 square plus 3 cube times 2 cube and so on up to 3 raised to the power n times 2 raised to the power n plus 1 is equal to 12 by 5, 6 raised to the power n minus 1. So we let the given expression as Pn as usual, and we compute P1. Left hand side is 3 into 2 square and is equal to 12, and right hand side is 12 by 5 multiplied by 6 minus 1, which is also 12. So it is 2 for n is equal to 1, let it be 2 for n is equal to k. So we have this relationship. Now we add 3 raised to the power k plus 1 plus 2 raised to the power k plus 2. So left hand side becomes k plus 3k plus 1. And this is our right hand side. Now it's a simple matter of algebraic manipulation to arrive at this result. Okay, once we have this result, by induction we have proven the result. Now I'll show you my website where somewhere you can download the algebra, trigonometry and quadratic geometry books. So the PDFs don't have the date, so you need to add date. And when I will upload new version, I'll update the date. I think algebra ones need to be updated here. And trigonometry and quadratic geometry also you can download. There are typing mistakes. So once in 15 or 30 days, you should come back and check if a new version has been updated. If so, you can download again and add the date here. Now I added my photo here. This was probably, I believe, at least 8-9 years old. Now if you want to ask questions, you can click this link and come to kundika.astroworld.org. And you can make a login here and ask questions. You have tags here which you can make use of: algebra, calculus, coordinate geometry, trigonometry, probability. Excuse me. So this editor supports math JAX. We can make use of LaTeX formulas. So with this, I will end this video here. And I hope that you are enjoying this series of algebra videos and finding them useful for your studies. So we will meet again tomorrow with 10 more questions on mathematical induction. So I'll take my leave and I'll see you in the next one. Till then, enjoy and keep learning.